Thank you all for joining today. We're going to have some fun talking through how Spring works in Azure. We're going to show you a full reference architecture that actually works. And then we'll actually have our friend from Best Buy come up and actually explain how he took a lot of this reference architecture and realized it in real life. So when you use bestbuy.com, you're taking advantage of this. So we'll have some fun. We'll go through a lot of these different projects. My name's Richard. I work at Pivotal.
I'm Asir from the Java and Azure engineering team.
Is your mic on?
Oh, my mic?
I mean, your booming voice is probably enough, but.
I'm Asir from the Java and Azure engineering team. I'm also a Java dev. Started in '95 with JDK1. Been playing with it ever since. Yeah.
Awesome. And then we have our guest we'll introduce here in a few moments. So this is the reference architecture. We are going to, I'll just give you a sneak peek of what we're going to show you. Asir, you want to describe this for just a moment?
Sure. I think very quickly, this is a real-time system. There are 4 key components there. You see the ones that are marked as Event Hub. It's a data ingestion pipeline, right? It's fully managed cloud scale ingestion engine. And the second one I want to point out is you see like a thunder symbol. It's the serverless piece. It's a piece of code that gets triggered when something happens in the system, right? It's used for real-time processing, storing, updating, things like that. So that's the second piece. The third one is the inventory data. The real-time system, in this case, we are imagining that it's an inventory hub, so you can see some meaningful insights as they arrive. The data is stored in the central piece, which is represented as the Cosmos DB, where it's a fully managed NoSQL database, and you can have it any of those regions. Any regions wherever your users are, you can keep them closer to your users. And the fourth piece is the dashboard. Dashboard is nothing but a Spring Boot app. It runs and connects to Cosmos DB using Spring Data modules. And it also listens to Kafka Stream using Spring Cloud Stream. And it can be run anywhere. You can run it on a virtual machine. You can run it on Kubernetes. You can run it on app servers, Azure Spring Cloud, Pivotal Cloud Foundry running on Azure. Anywhere you can run it. So those are the 4 principal things that are in this slide.
Good. We'll revisit that in a minute. Because I mean, I know we're all used to thinking we're hopefully just building business logic in our apps, but we know that there's so much more to all of our app infrastructure than this, right? All the stuff you're stuck, maybe not stuck, but you have to interact with, right? You've got to figure out monitoring. You have to figure out deployment. What's your identity management system? What are you using to store your secrets? All of these sorts of things. So how are we looking at the whole landscape of things? How does Spring solve some of this? And then specifically, what has Microsoft done to inject Azure into some of the key parts of this? So that while we really want to focus on the green, we'd prefer that the rest of it also be taken care of as much as possible. So I mean, we could talk about why using Spring. Gosh, I hope I don't have to do that too much at this conference. But we do know that hey, Spring Boot's a remarkably popular framework because it simplifies stuff. I'm a .NET programmer by trade. I learned Spring when I joined Pivotal, so they wouldn't make fun of me. And now I actually prefer it, I guess, at this point because of how quick and easy it has made it for me to build all sorts of software. And what's great to have is the same framework for all the different types of apps. That's what we'll see in practice here from Asir and team, whether it's functions, batch jobs, streaming apps, web apps, APIs, monoliths, microservices, it doesn't really matter. I can use Spring for all of those. And I can take advantage of some of the Spring Cloud things you saw today, Spring Cloud Gateway, Spring Cloud Stream, all sorts of things that actually do distributed system programming fairly simply. So this is the reason you probably are using Spring. Asir, why in the world are people paying you to use Azure?
Sure. So global and instant scale. Azure is available across the globe, about 54 regions, and it's available about 140 countries. That's definitely larger than the other 2 clouds combined at this point. And we have managed services for almost everything, right? Whether you are ingesting data or storing data, or you're monitoring data, or you are building a messaging system, or you're running Spring Boot apps, our data storage, limitless data storage. So we have all those managed services. And it's also the hybrid. Every time we talk to many of these enterprise customers, what they tell us is their systems are always hybrid. They have some systems running in the cloud and some systems running on their on-premise, and they want a seamless connection. Now, right in the middle is sitting as the Active Directory. They have Active Directory on the on-premise, and we have Active Directory in the cloud. There's a way to connect them, so when users come, it seamlessly transitions them from on-premise to the cloud. And of course, the security is across the board. That's one important point. And when you are, as a Java developer, when you're using, you can use the tools and all the frameworks that you already know and love, whether it's Jenkins or Maven or Gradle or IntelliJ or Eclipse, any of those things, so make you feel very comfortable there.
Yeah, terrific. So let's go through some of the specific projects, right? The specific Spring things, and what are the integrations in that you're going to find in Azure? And you'll see demonstrations of some of these. Some of these are the first ones. I use this a fair bit. I do use Eclipse when I'm doing a lot of Spring development, but I'm also using Visual Studio Code now. It's a free editor. They're very careful not to call it a development environment. But at the same time, you get these things that Pivotal and Microsoft have both contributed around Spring, around Java. So when I use Visual Studio Code, it's really easy to even get the Spring initializer experience. I can use the plugin to walk through the same start.spring.io experience in Visual Studio Code, generate the project and stand it up, be able to do live debugging, be able to do type ahead, code assistant. So if you're looking for a lightweight way to actually start introducing Java and Boot to your teams or even yourself, I'm actually a pretty big fan of using code.
So I think everybody knows Spring Boot, so we don't have to explain Spring Boot. When it comes to Azure, you can run on many of our compute types. You can run it on virtual machines. You can run it on Kubernetes if you want the control so that you can control everything. Or you can run it on PaaS platforms like app service, right? We have a Linux. We also have Pivotal Cloud Foundry running on Azure as well. And then we also have the new service. It's the Azure Spring Cloud. So particularly if you have Spring Boot-based microservices, then that's a great platform for you.
Yeah. Now let's talk a little bit more about that in a moment. So the support for Spring Cloud is pretty good on the whole. We're going to go into a number of these. Obviously, we're all using Spring Cloud for distributed systems. That's why we do it, right? It makes these Netflix-style patterns a lot easier, so you're not figuring out circuit breaker, I'm not figuring out remote config, things like that. Azure's got a lot of stuff. We're going to drill into these in more detail, but for messaging, function support, configuration, the Azure App Configuration Service is actually pretty cool. And there's again, you can use this pretty easily from boot, but it provides a remote config store. Again, kind of behind the scenes in a very highly scalable way. And then, of course, the managed services. We'll talk about Azure Spring Cloud. This is kind of first of its kind to have this sort of language-specific, platform-specific runtime in a public cloud. Those don't really exist yet. Tell us about this, as your team was on the hook for building a lot of this with us.
Right. We announced this yesterday jointly. It's a fully managed service built on top of AKS. It's built jointly, run, operated, as well as supported by Microsoft and Pivotal on this one. All your Spring middleware components, when you're thinking about service registry, config, your circuit breaker, any of those components, right, they're all managed for you. So all you have to think about is just bring your jars and just bring your source, and all other things will be taken care of you, whether it's dynamic scaling, app lifecycle, or monitoring, wiring up for monitoring. All of those things are taken care of. It relies on many of the Pivotal components as well. When it comes to all the Spring Cloud modules, the KPack, the build packs, the Pivotal build system, all of them are available for you.
Yep, great. Now I'm excited about it. I've been using it as well, trying to break it, and so far so good. So Spring Cloud Stream, I don't know, this is one of my more secret favorite projects, not anymore because I'm saying it now on stage. But Spring Cloud Stream, so what do you use this for, right? How do I connect distributed systems through some sort of messaging subsystem? RabbitMQ, Kafka, Azure Event Hubs, Kinesis, pick your poison. How am I connecting those sort of things in a very consistent way so I don't have to be an expert in any one of those? So in an Azure world, you can actually use this, again, Spring Boot starters, you have all this sort of experience with this, that you can connect to Azure Service Bus and queues. These are resilient queues, cross-region, right? So if I'm a developer saying I need to connect A and B through some sort of distributed broker, really easy to connect to queues or more sophisticated routing with kind of content-based routing through topics. So that's all just built in if you want to use Azure and do messaging. Same with stream processors. So you can think that Azure Event Hubs is a lot like Kafka. It's a distributed log, right? Write-ahead log, immutable log. And so if I'm trying to use that in an Azure world as well, and this stuff's highly, again, well replicated, highly available, remarkably scalable in terms of throughput. I mean, you can really throw a ton at this. If I want to use this with Spring Cloud Stream, these are annotations. Like, I don't really have to understand anything about this subsystem. I'm really just enabling a binding, creating a stream processor, and I'm talking to Azure Event Hubs without having to understand any of the machinery. And as you had mentioned, because this actually does have a Kafka interface on it optionally, I can even use a Kafka sort of driver experience to talk to this through Spring Cloud Stream, and it just works. So if you're trying to connect brokers together and you're using Azure, Spring Cloud and Azure are doing a pretty good job here. All right, tell us about Spring Cloud Function. Your team did a lot on this.
Right, so Spring Cloud Function, it brings the power of Spring Boot to the serverless world, right? So you have the dynamic injection, auto config, all those comes here, and it can run on any of the clouds, including Azure. So we worked with Pivotal engineering team to make sure that it runs on Azure functions. So when it runs on Azure functions, right, we have native integration with all the Azure services, whether it's data or messaging, all of them are natively integrated, so triggers can wake it up, you can bind the data in and out, all those things are available. At the same time, Spring Cloud Function can also run as a web endpoint, as a task, any of these things so that it can help you easily run in the cloud.
Yeah, if you're getting into serverless and kind of ephemeral, short-lived compute, getting all the fun stuff of Spring, as you said, auto-configuration, dependency injection, but still using these platforms is pretty great. Spring Data. So you're doing a ton here, maybe the most, if you look at kind of the breadth of the sort of things that Microsoft does for Spring Data. So obviously you're using this to make data access easier, right? You're trying to make sure it's simpler to, at the same time, access those things, but not necessarily just make them all generic. I want to get the benefits of all of those. So if I look at where Spring Data support comes in with Azure, I can do relational. So if I'm talking to Azure SQL, MySQL, Postgres, those work perfectly fine with Spring Data as sources for both reading and writing data, transaction support, all that sort of thing. That works great. Probably the most interesting thing in Azure is Azure Cosmos DB. This is their planet scale replicated database that you're literally just immediately replicating data, both multi-master, read, write, all around. I hope you jumped back into this mode here. It's a good thing I was on the last bullet. Got the reveal. So, I mean, Cosmos is a super interesting database, but what's pretty cool about Azure with Cosmos DB is it actually serves up multiple interfaces. It serves up a SQL interface, it can look like Cassandra, it can look like MongoDB, even Gremlin, so if I'm doing graph. So that's pretty cool stuff. So Cosmos is a pretty powerful database. I don't think it gets all the credit it deserves just because it's kind of an interesting cloud database. It's not something you always are used to using. But what's really been some cool work this team's done over the last year or so is this R2DBC work. So I can actually have true reactive data access to Azure SQL and PostgreSQL. So again, no fakery here. This is all just stuff that works reactive all the way through in the Azure stack, which was good work by that team. Anything you want to add here? I know your teams, again, spend a lot of time making sure you're mapping Azure services to Spring Data.
The key point is when it comes to Spring Data, when you come to Azure, there are several areas that you can integrate, right? And if you go to start.spring.io, when you type the word data, you will see all these listings. For every one of those listings, there's a managed option on Azure. Yep. So that it's makes your life extremely easy.
Good. So tell us about Spring Caching.
So when it comes to Spring Caching, there are two scenarios, right? One is app cache. The other one is externalizing your session management, right? So for both these offerings, we have Azure Redis Cache. It's a managed service. You don't have to worry about any hardware or service management. All you have to say is, I need a Redis cache. The Redis cache is available. And then you can configure Spring Data Redis if you're doing app cache, or if you're using Spring Session. Just use Redis as a store to externalize, so everything will be externalized. From then on, all you have to do is when your end user hops from one instance of the app to another instance of the app, the message correlation continues with the user.
Good. Spring Resource as well. This is one that actually is available again as a Spring starter. If you go to start.spring.io, I believe you're able to use this. I've done it from there. So when I'm thinking of this is often for low-level resources, right? You build your own resources in Spring. Obviously, there's out-of-the-box ones like file system. And so the way you would use this with Azure is you can actually use Azure Storage as a resource. This works great, right? I need blob storage, especially multi-replicated, right? I'm going to be able to access this in a highly available way. It's very durable. And so this one's pretty easy to use. Again, Spring Boot Starter, Spring Initializer. So if I'm looking for a highly available blob storage, object storage, if you will, using Spring Resource, using this with Azure is pretty clean and easy, especially again when you have persistent logs, if I'm pulling image files, like all these sorts of things, video files, things I might want to use blob storage for. This makes it really super easy to interact with that. Spring security. This is one that you get pretty excited about. As excited as you get, but you get excited about this.
I'm very excited about this one because whenever we talk to customers, one of the challenges how to enable end user authentication and authorization for the app, right? It's a pretty challenging one, but when you come to Azure, we have a way of making it easy. So when you turn on using Azure Active Directory for your directory-based authentication, or if you are using B2C, particularly social media accounts, if you want to enable that account, all we have to do is add a starter, which we're going to show you today, add a starter and just configure it, and the end user authentication just kicks in. The next piece, which is that you have, all your apps have lots of secrets, connection string, client secrets, things like that. Now, how do you store them and manage them in the cloud and make sure that you don't have an exposure? So that's where we have Key Vault, and we have integration with Key Vault, so you can load your secrets and pull it at the launch time of your app directly from Key Vault.
Awesome. Yeah, lots of good stuff here. Micrometer. Yeah, more monitoring and metrics. This is kind of a foundational piece now as we think of metrics collection in a boot world. And again, this is really collection, right? I'm still going to feed this out to other tools that are going to visualize, store, analyze this information, but this has become fairly standard across Spring Boot now. But you can now feed these metrics right into Azure App Insights, which is a really impressive set of tools that have all come together in Azure for log analytics, monitoring, alerting, things like that. So that's now just a pump, right? You can just pump this information coming out of your boot app into these experiences thanks to that. So again, Spring Boot Starter, a lot of these cases, you're almost just adding this to your app as a dependency, and things just work when it runs in these environments. So pretty convenient if you're doing long-term log retention or troubleshooting, trying to figure out your observability story. This is great. Documentation. Your team does a lot of docs.
Fabulous right there.
I guess you don't do any of the writing. But, so tell us about the documentation a little bit.
So we have, right on our doc site, a dedicated landing page for Spring on Azure. It outlines many of the things that we touched on, and it outlines by giving you the getting started information, lots of samples, and lots of conceptual guides so that you can get started. We also have a mirror page on cloud.spring.io, which lists similar things and then navigates to the details to docs.microsoft.com. Right? And Barbara's team is the one that drives all those efforts.
There's no public cloud that puts more effort into Spring than Microsoft does, so kudos to you all. So let's go back to this, because we're going to show this off now. So I mean, again, as we've looked at most of these services as we just talked about. We talked about running the boot app on something like Azure App Service, using Cosmos for multi-region replication, using things like functions to actually do things like point of sale and triggers, and storing those things in event hubs, again, that append-only log that you're distributing and accessing. So we put all this together, multi-site. Let's start showing this thing off.
Okay, let's do it.
And of course, you do want people to interact and try to break your stuff. So I think this will be the first URL that you all can hit in a mobile as we're doing this demo, and you're going to be able to actually tap into this stream as well and see what's going on here.
In that architecture, you have to imagine that a coffee shop company, a successful coffee shop company is deployed across the globe. In this case, they are deployed in Boston and London. So if you open this URL in your phone or your computer, you're going to see a real-time dashboard showing the transactions that are happening in Boston as well as in London.
And what we're going to do is add a new one, right?
We're going to deploy to Singapore right from here, and you'll see how things change real-time in the system itself.
Terrific.
Mm-hmm. So I'm going to start showing you. First one to show is we're going to deploy a Spring Cloud function to Azure function. So this is nothing but a Spring Boot application, which is a Spring Cloud function. It actually ties into an append transaction, which gets woken up by an event hub trigger, and then it binds the data to Cosmos DB output. And we have a pom.xml where we are declaring the use here. So you can see the plugin coming through. We're also using the adapter that was built by Microsoft as well as Pivotal. So that way we can now deploy to Azure.
So again, with the functions, I know you touched on it briefly there, but the idea is you're almost decoupling some of the code from some of those bindings, right? So you have some annotations that say this is triggering from event hubs. When that thing happens, then trigger this function. All feels very native if you're a boot developer to just kind of feed that in there with annotations.
Right. So if you're watching the tracker, we're going to now deploy that.
So you're deploying this to the new location?
Yeah,
in Singapore?
we're going to deploy to Singapore at this point. So the first thing I want to do is package it. I'm going to shorten the go offline. So start packaging it.
And of course, because they're functions, you're only you don't pay for this anyway, but in theory, you would only pay for this when it's actually responding.
Using it, right, yeah.
Right. Otherwise, it just turns off and doesn't cost anything.
Correct.
So what kind of things did you have to change when you built that adapter? What was some of the linkage between how Spring Cloud Function works and what Azure expects?
So it's the invoke path, right? So when it comes through Spring Cloud Function, we have to connect the invoke path into the Azure function path. After that, it proceeds with that. Yeah.
Yep.
And the bindings as well, similarly, we want to make sure. And we also want to make sure that we have an experience as well. So the Spring Cloud also leverages all the experience that we have today in the system.
And you support most of the bindings?
Yeah,
that
we
Function
support
supports?
all the bindings. Any binding that we support for the Java, or all the data services, messaging services, all of them are supported.
So you can trigger functions off a storage change, off a database change, off a log change.
Right.
Yep.
So I'm going to deploy now.
Okay. Deploying to Singapore here from Austin, Texas. I expect this to be
Deploying
extremely
to
fast.
Singapore. So what we did is we provisioned the event hub as well as the Cosmos DB read or write access in Singapore before we came into this room. It took about 5-10 minutes. And now we are deploying the functions into Singapore, right? So let's start looking at the tracker as well while we look at the deployment. If you are seeing it right now, this is the screen you'll be seeing, right? Where you can see the transactions coming through on your phone or your computer, right?
Just for the two locations.
Just for two locations. One is Boston, the other one is London. Now, Singapore is being provisioned at this point, right? And you can see the live transactions coming through. They're all coming through the real-time systems that we showed you, right? Right. So while that is happening, we can start looking at how does this web app look like, right? So let's go there. So here is the web app. So the web app is nothing but a simple Spring Boot app, right? It's very simple Spring Boot app. It is talking to Cosmos DB using Spring Data Cosmos DB. It is listening to event hubs using Spring Cloud Stream Binder using the Kafka interface. Now, the Kafka programming is very simple here. All you have to do is declare that you are a listener. This is all the code you need from here to here. Your event stream is coming into the Spring Boot. After that, it's up to you to process the event stream.
And none of that's Kafka code. None of that
None of this is Kafka
it's just Spring code.
It's just plain Spring Cloud Stream Binder, right?
Yeah.
There's nothing specific to Azure or nothing specific to Kafka.
Right.
It's purely Spring Cloud Stream Binder, right? Now I can also show you the dependencies that we had to declare there. So if I go here, the main dependency is the Stream Binder as well as the Kafka. That's all we need. Right? After that, that small piece of code start listening to Kafka, and I'm getting the transactions, and all I have to do is process the transaction at this point. Right?
And because of this, you could test this locally. And I wrote a blog post last week, the week before, on using Confluence Cloud on Azure. Exact same code. Like there's zero code change to make this work in any sort of environment that has that, because we've abstracted it all out with Spring Cloud Stream, which is nice.
Right. So let's quickly go back to the screen. And I think it's still
deploying.
the other screen. I need to get the. Yeah, I think it's deploying.
Still thinking.
Okay, while it's deploying, let's start looking at other pieces. So underneath this, there is a Cosmos DB, right? The Cosmos DB is as the NoSQL managed NoSQL data store. Here it is, right? So this Cosmos DB is currently deployed across the globe. If I were to look at how it is deployed, you can see it in the map that it's deployed in Boston, it's deployed in London, and just before we walked into this room, we actually extended it to Singapore as well, right?
By literally clicking the button.
Just literally, I just click the button and save it. If I want to click to another area, I just click this button and save it. It'll start replicating immediately, right? Now, how did I connect to this? That's the key, right? So let me show you the piece of code that we had to do it. So the first thing is it supports Reactive, right? So I declared a Reactive repository here, which is the product inventory repository, which extends the Reactive Cosmos repository, which comes from string data, Cosmos DB. And then I had to write we had to write a inventory controller, which actually does the Flux code right here, right? Where it is pulling in, and as it is iterating, as you need it, it'll just pull from the back end. So it's completely reactive at this point. Now, to make this happen, in the pom.xml, all we had to do is we actually marked this as this is the starter. This simple starter is all we need to bring that into focus.
For reactive or non-reactive?
For reactive or non-reactive, that
Just
supports
that one.
both of them. So in this code, we only wrote it as reactive. If you go back in the history of the code, you would see the non-reactive code sitting in the commit as well.
But the developer doesn't have to pick. They can obviously switch.
Correct.
Yeah.
So let's go back to the deployment right now and see where we are. All right, we deployed. So let's go back to the portal, how it is. All right, Singapore is already in.
Doing a lot of Danish right now in Singapore.
Singapore is coming
I don't know what's
through.
going on there.
Yeah, well, it's a new shop, so things are coming in, looks like, and it's all selling faster.
What's
You can
a
see
protein
Singapore.
box? What's a protein box?
Protein box, I think you have to ask the Starbucks guys. They sell a protein box for $6, $7. Right?
Interesting. All right.
By the way, these coordinates are almost like some real shops out there. You can see them. Yeah. Okay. So let's notch it up a little, right?
Okay.
Let's enable enterprise-grade authentication for this, right?
But we're developers. We just run as admin and don't
No?
do that. Okay.
I know, right now we are admins, right?
All right.
Let's enable, and if you want to enable your customers who are coming, let's say in this case, imagine that they are using your Facebook accounts, LinkedIn accounts, email. Let's enable the social accounts for it now, right? So we're going to do it right away, right? So let's see it. I have already done it, but I'm going to show you, but you can also try it right away. So one of the things here is, if I go back to the slide deck, we have another address here. Can you try that address? Everybody.
Yeah, because and also reference everything you're showing here is in the GitHub repo.
Yes.
Right, this
It's
whole
all
app.
in
So you
GitHub
can run
repo.
this all yourself as well.
Yeah. So if you have already taken that, I'm going to log in now. Okay, myself here. So here I'm going to take a new window. So it's AAD from the previous one. HiHub-AAD.
And this is for them to log in with social
Correct.
IDs?
Yeah.
Where we'll be harvesting their email address and spamming them ruthlessly? No, that wasn't.
No, that's not the intent.
That's just Pivotal. Got it.
So I'm going to type right here and go through the same experience like you're all doing it. So if I type it, see, it shows me, right? I click on Microsoft account. Let's start from there. So it might have it in my cache, so it might be easier for me. So I'm logging in. Voila, it now knows who I am. Welcome, my name is there, right? Now, how did I do this? This is the key.
How did you do this?
Right, that's the key. Right? So let's go. So the first thing I did here is I actually declared these two dependencies, right? That's the key, right? I brought in Spring Security, and I brought in the B2C starter as well. Those are the two first thing that I did.
And B2C is for the social ones.
It's for the social
versus just
one.
regular AD.
Right. We also have another starter which will connect you to the AAD directory itself, so you don't have to worry on that front as well. So let me go back to the code. So in the code, I had to declare a security configuration, right? So here you can see in this case, right, we just added a bit of code that if AAD is enabled, please authenticate and authorize it. And if it's not enabled, just take the regular path, right? We're also leveraging the Spring profiles. So the way we defined is we defined a new profile called AAD, and that's when this kicks in, right?
Nice.
And if you don't have that profile turned on, there's no AAD, you just go in, it'll be like anonymous. That's how we did it, right? Now, what is behind it, right? So let's go to that one. I think let's minimize. Okay, here is I think I already opened it here. So here is the AAD B2C. So we have defined an application there. The application is called Inventory Hub, right? And we have enabled all the endpoints so it can come back to it. In terms of the identity providers, you can see that we support many, but we only wired up a few here. The ones that we wired up that you saw on the page is Facebook, Google, LinkedIn, and Microsoft MSA accounts, right? So that's how we wired it up, and that's how it just kicked in, right? Now, the next question is, how can they handle the secrets?
Right.
Safely and load it so that it's not fully exposed to
Clear text in property files.
Yeah.
That's
so
not right.
I'll show you where we started, right? The way we started is something like, we actually had a file like this, right? You see everything is in an environment variable, right? That's where we started. And then we also defined a profile, right? Now, if you load this way, what happens is there is still an exposure. If you are running a production system, your developers will have access to it, right? So this is where we have the configs, right? So let's open the config. Config is right here. Here's the config. So we loaded everything in the config, and you can see that it's in the Explorer.
This is the Azure App Configuration Service,
This is the
again,
Azure
recently
App.
released.
Right. All you do have is just have your config data, and you can load it in, and you can continue to refresh as well. I'm going to open it up and show you here. Since all the secrets are not here, I'm okay to just open up and show the values to you. These are only config, right? Purely config. And you can see that it's actually, when it comes to the key, then it goes to Key Vault.
So you're storing a pointer to the
So it's
actual
a reference that loads it directly from Key Vault. So the Key Vault is right here. And you can see all the variables that I needed are right here. And you can see right here, this is the Key Vault where all the secrets are here. So you would see only the secrets, right? They're all here. They're all stored right here, and it gets loaded right from there, right? All right, so that's the configuration, right?
Now, is that happening transparently in your code? So in
It's
your boot
happening
code-
transparently. All you have to do is you will use a managed identity, and you would assign that managed identity. I actually show you that one right here. If I go to the access policies, you would see that this is the app. It has the read access. Right? So that as identity can be applied to any of your apps. As long as it has that identity, it can log in and get the data. And no, it's zero config at that point.
Got it.
So the other question is, okay, if you are running these multiple deployment systems all over the world, how do you monitor? How do you figure out when something goes wrong, right?
You just ask the ops team to do it.
Yeah, but you still have to help them, right?
I guess so.
So this is where we have wired up for app insights, right? So you can see all the data coming in, right? So you see the functions, you can see the web, you can see all the time it took, or what is the count, right? Now you can also see the dependencies as well, right? It'll load the dependencies for you and where the time is taken. and the various roles played by many of the computer machines, and you can double drill down that lane. Now you can also choose one particular one and say, hey, what happened to this function, right? What happened to this call, right? All of those things can be. Or you can also go for a live stream, and the live stream is here. Live stream is running. It's actually picking up all the data and showing it to you right there what is happening in your system, right? Now, how did we make it happen? Is the
Magic.
It's a little bit of magic, and I have Trask right there. He knows all the magic behind it, right? So what we did here is we went and we just added a very simple a Spring Boot starter. It's called the micrometer starter. Azure Spring Boot metric starter, that's all. That's all we did, nothing else.
So what's it pumping in there that Azure wouldn't have picked up naturally? Because it obviously knows functions are running and things like that. So what's the application level information that's coming out?
It's kind of getting the HTTP tracing, it's getting the JVM, the Tomcat, all of those information are coming through. We have a long list.
Yep.
All of them are coming through, right? So I think that should cover all the things that we showed you right here. Yeah.
Tremendous.
Right.
Great demo. That's why you had 14 windows to open up while we were getting ready. So it was worth it.
Yeah. So
Thanks,
let's go
Asir.
back.
That was great.
Side. Okay.
All right.
At this time, Richard and I would like to welcome Vaibhav to stage. He's from Best Buy.
Hi, everybody. So I'm Vaibhav. I'm the lead architect for the order management systems in Best Buy. So just to give a little bit about Best Buy, and we may need a slide. So Best Buy was started in 1966 as a company called Sound of Music. Nobody knows that. They had some tornado, and then there was a tornado sale, and they sold the product saying it's a Best Buy product, best sale, and the name stuck after that, Best Buy. So they renamed officially as 1983 as a Best Buy, and from there it's going. And if you see, the Best Buy mission is it basically enriching the lives of the consumers by the technology. They solve all the technology needs, everybody. So if you see Best Buy, it started like 1966. Think about it, 1966, what was the infrastructure will be? What would be the application will be? All mainframe. So you would think Best Buy is all mainframe. No, we are very happy to say, few years back, Best Buy shut off their last mainframe. They don't have any mainframes. What are they using now? The main thing which is say, I don't want to manage stuff. I don't want to do it. I don't want the technical challenges, the technical difficulties which we had it earlier in the beginning. I don't want to manage that. If I don't manage it, I will not have those technical challenges. How do I say? And we go to next slide here. Yeah. So we said, we want to follow 4 simple principles. I want zero administration. I don't want those technical challenges. Somebody who is expert in managing administration, let them do it. The next one, we want to auto scale. We have Best Buy, if you see retail. How many times you guys have shopped on the Thanksgiving? Long queues, if you go to stores, you go to website, all the applications slow down. Why? We get from somewhere 1,000 users per minute or per something like that to 1 million users per minute in that 1 hour time frame scale. How do we do it? I want auto scale. I don't want somebody to start creating servers at that time. It will take like 10,000 people to create 1 million to scale up the 1 million load. Paper use. We don't want to have those tens of thousands of servers all the year round. We want it for that per time. So we want the paper use. And then, so Best Buy, if you guys know, had some serious challenges few years back. They were thinking, oh, they are the brink of extinction. There was a big turnaround. At the turnaround part, the core of it was there was also a turnaround inside the company. As a company, we don't sell even technology. We at the heart are a technology company also. We think technology all the way. So we want to, and we talk technology, we want very quick deployments, velocity of everything. So let's quickly go to the next one, which is the how Best Buy use this Spring and Azure. Why we use Azure? We talked about the 4 things there. Why we use Spring? It's easy. It's all, everybody in Best Buy knows Java or Spring. We have no need any additional skills. What we did, I just simplified one of the application architecture here. It's a lot more bigger than this. It took me a lot of time to simplify. So, so what it did is, I have got 4 carriers. It's actually 44 carriers in there. So we have got a lot more integration, and they have so many different logics, rules. It goes through, the biggest thing is, as to build an application, we need 3 big things. I think some of the things Asir mentioned earlier. One is, what we want? Ingestion, a way of ingestion. I want to ingest the data. I want to do all the ingestion of the events, all the ingestion of it. So we use Kubernetes, we use the Spring Boot, Spring Boot on Kubernetes, we just deployed it pods. It was so quick. Typically, to ingest the data, when we use a middleware team, it takes 1 week at least to get data ingestion, building some adapters, integrators, and all. We use Spring Boot on Kubernetes. We deployed in 2 days. Every integration we did in less than 2 days. That's what we did. The next thing, we want processing. Once you get the data, you want to process something. You will have some business logic, some rules, something around it. If you don't have it, we don't need the application. So we just need processing. What we did, we used the functions. Azure Functions for that. What we deployed it, we deployed in Spring Cloud Functions. How quickly we did it? It was fast. It was very fast. We didn't have any specific code for Azure. It was the only skill the person needed was the Spring Cloud Functions. That's what we deployed with. The next thing, third thing which we want to do is persist. Yes, we want to store the data. We took the data, we applied business rules, now we want to store it. What do? We use the Cosmos DB for that. And it's such a proprietary logic. We have to use Spring data. The guys didn't know they're using Cosmos DB. They just use Spring data. They use the Spring data, they use some appenders, they use something, and behold, it was there. We got this whole application up and running within weeks. The similar logic was built previously. It took months. This was done within weeks. It's such a big, simple thing and there was no maintenance, there was no administration, nothing in it, and there was no special skills needed. What else we needed? There are other things also. Yes, secrets. We use Azure Key Vault for managing all the secrets. Oh yeah, Best Buy has got a lot of customer information. All of you guys have given information to Best Buy. And we want to make sure it is safe. Secrets is the one thing which was nobody unauthorized can access the data. What we use? Yeah, we use, somebody comes from internet, bestbuy.com. They use the front door and app gateway to do that. So that all is there. And we use app service. So app service, we connected the database with the Spring data. Okay, so do you guys have any questions around for me? Or you guys think you go on everything?
I mean, I've learned everything, but before this, so why were you using Java and Spring in the first place?
Yeah, we did some of the COBOL things and all those things. We used some of the other things. We actually, all those guys, as somebody said, they retired, or they are like very happy in some way in Havana or somebody in the beach or somewhere. So what we did is, so before this, right? So we have all the things, but now the biggest thing we have is, as you said, Java, Spring skills, and that's it. That's all is there, and it's like everything almost can be built up there. We have like building hundreds of applications, and all of them is being using Java and Spring.
Did that ease that transition? So I mean, using cloud from what you're doing on premises, I'm assuming that this was not a retraining effort.
It was not. It was not. It was a similar, same skills, nothing, just new modules to be just imported in, that's all.
So how long did it take to build the whole thing? I heard you said weeks. How long did it take?
Yeah, so a similar function before that was built earlier in around 4 to 6 months. It was a less complicated, less more business rules and all. This one, we brought it up from the concept to the finish in less than 10 weeks. It's almost like 2 to 3 times less than what we actually used earlier. So it was, it just, yeah, oh, there's we had some slides for that, I forgot that. Yes, so it was like 16 plus weeks it took before, and we took less than 10 weeks for this one. Exactly almost same integration, same logic, more complexity now, but we did it very faster.
Yeah.
And we have also, one of the big things is we use some of these things like Spring Cloud Functions. it helped us force, making a segmented code. The Azure functions worked very seamlessly with it. It helped us making sure it kept a lot of discipline. We had, I wrote a code around 20 years back or something like that. The code still runs. It's a one module, and it's around, I think, 1.5 million lines. Somebody wants to, needs an issue, they still call me, because nobody wants to learn that 1.5 million lines of code. Here, it's all modular, each function, everything as smaller as possible. It's like everybody, it runs independently, all in nicely.
So that's not all one function in Azure.
We tried.
He tried.
I'd like to see that. So did your, 10 weeks is still pretty fast, but did you notice your scope changing, and were you doing test-driven things with functions? I mean, are you able to do a feedback loop fast enough?
Yeah, so what we did is we said, okay, when we started, we said no scope changes. That's it, we're going to go. Come on, that's not going to happen. We had a scope change. This application actually had a scope change every week. We had every week scope changes. What we did is, here, with the Spring Cloud functions, because of the discipline which it brought, because of Azure functions, the integration with it, it helped us in such a modular components that each component was independent of its running through it. And we could change one function, one component, as whenever it needs. And I could bring changes. I don't need to touch every application. I don't need to do anything in the whole application.
How often were you deploying to the cloud?
So before this, we used to deploy a month. In this one, we're deploying every week. Actually, some of the build processing teams were like, you cannot deploy every week. We don't have the process for that. I said, really? You guys change it. We'll deploy twice a week if you can help me. So we are very fast in this.
Yeah. How did you scale during that load? Like, how did you respond to that? Did the application scale
I have
successfully?
some good slides. There's some good snapshots to that. Let's go to the next one, more of it. I've got some. Keep moving this chart. I've got some charts.
I'm just building it up.
Yeah, there we go. Nice. One more.
I think the next one was agility.
One more.
You do have a pretty chart in here. Let's jump to that.
Okay, so scale. So first is we use auto scaling, obviously. So one of the things we learned is that typically in our world, we have tens of hundreds of servers. Every time the load increases, our performance goes drastically. Load goes 10 times, performance goes 10 times down. This one, we found it is different, because I know some of the things we use the disciplines of the Spring and all. We use the disciplines of the Azure, and Azure has an infinite capacity. What it brings is, as soon as the load increases, our performance actually went up. So because with the Spring Cloud functions and all, because my functions are there, it basically it can just process and move on to the next one. My average performance is in every day like between 10 to 15 milliseconds for some functions. But if you go to the next slide, in a peak, we had a peak run for millions of records. We actually broke sub-second. Oh, sorry, they say sub-second? Sub-millisecond. We were actually running in microseconds. Our average performance actually went into some microseconds, because at that time we had a scale of around, from 5 functions, I went into 100 instances of functions for that 8 hours, 6 to 8 hours. And then my average thing reduced to like almost per event execution was around 500 to 600 microseconds. We did less than a millisecond thing.
So did you have to reserve any capacity for all these kinds of peak loads that you're running through?
So let's talk a year back. A year back, I would have bought hundreds of servers. I would have bought for hundreds of servers for the whole year. I would have kept it there. I would have paid for it like millions of dollars across the things for that and all. Yeah, that's what would be there. Here, nope, we did not. What we did, we just had it all auto scale mode. Functions, we actually did not know that we are going to get, so what happened is, the funny part was, we did not know we are going to get those millions of records. We were actually only processing hundreds or thousands of records, and when we started the application, somebody said, oh, you know, the vendor, I have a backlog of 20 million records, events. Somehow we have not sent it to you. I said, okay, bring it on. The only thing we did is, we were just watching it come through it. We scaled from 5 functions to 100 instances of functions automatically in that 6 hours, 8 hours. We processed it. We did it, everything and then after that, it went back to 5 functions.
Yeah.
The load was processed.
Just a couple more questions. So what did that do to your cost and spent? Like, this is more unpredictable now, right? You're not necessarily sure what bill you're going to get each month. Did that just change your expectations from a big front-loaded cost to probably cheaper but less predictable?
It's actually, yeah, it changed the whole paradigm for us. What it did is, it basically said, now I don't have to plan for 6 months upfront for the cost. I'm going to get a load, I will use that. It basically plays in the plan of actually how much I'm going to pay, of how much business value it brings in. Previously, I just get an upper hand, a whole expense and capital and all those things I have to put up there. Here is actually, I've got this much business and actually I'm using it for it. Mm-hmm. I actually have an ROI every time.
Yeah. So one thing we hear from developers is when you have such a massive deployment, it's very hard to troubleshoot and find what's going on. Tell us about your experience.
Oh, you had the one slide there which you showed up app insights. Yes, for a cloud scale, there's always, to be honest, we had a little rough time in the beginning to go through that, how to debug and all, but within a few weeks, we learned it very easy. Using the right appenders, putting the right data in the app insights and all, it was with the whole, it's all standard micrometer things. It's not proprietary anything much. So it was very easy from that point of view.
Yeah, so last question, because I know we're just about out of time. What would you, for people here who are Spring developers or looking at starting to use cloud, not everything's going to be perfect. We don't need you to say that. So, like, what's harder, right? What are those lessons learned? What do people need to walk away with this from?
Yeah, well, that's a very good question. So there's nothing like a silver bullet, as a lot of people have said, right? There's nothing like that. But before touching anything cloud, don't go to the proprietary things. I think every cloud components have a Spring integrations. We use the Spring boot for ingestion, and it was very easy to integrate with some of the ingestion components on the cloud. We use Spring data to connect to database. No need to have a specific Cosmos DB and all. Spring Cloud Functions we use for routing functions. Yes, and I said it's not every bullet. Okay, so we learned something different. Not everything is right also. You need to find out what is the right thing for your right component. Spring Cloud Functions worked very well when we had some of the functions on a dedicated capacity. Some of the functions we had in a pay-as-you-go capacity, we found a little overhead for that Spring Cloud Functions. But that's fine. That was also a benefit there. We learned it and we tweaked it. So make sure you use the components and use the right components, but I would just say use Spring components more than the proprietary ones. Almost every component has a Spring integration.
Yeah, so hopefully don't pick your infrastructure before you pick your business problem. Like, you just can't say it's all going to be functions until you figured it out. So, you've learned that over time.
Oh, I did a lot. Great. Thank you for that.
Awesome. So we have got a couple things for follow-up. So we have folks can watch Josh and Julian talk about Spring Cloud. We renamed the session yesterday after we actually announced Spring Cloud because we couldn't give it away, so it's got a different name now. Go check that out today. Obviously, jump on the Spring site. That's the link to the Microsoft documentation for Spring, pivotal as well. Hope this is educational stuff. It's so free. There's free trials all over the place for Azure. You can try these things out. Obviously, Spring is free. So play with this stuff. Learn it, break things, try to figure out how to use it best. But thank you for watching. We're up here for questions.
Thank you. Thank you for joining us.